Yes. A very good afternoon and very good afternoon online. So last class we were discussing about the atmosphere component, right? The basics of climatology. Today what we'll be doing is a basic component from the geomorphology we'll be taking up and then we'll learn. So before we enter into any further topics, ये काफ़ी basic चीज़ें हैं हमें जानना चाहिए. And especially the structure and interior of the earth, this is what we have to know. And what I'll be doing is I'll be taking up this topic and I'll explain it as lucid as possible. And the technicalities in this topic will be taking up in the further classes, right? Only today I'll go into the very, very basic parts of the interior of the earth and how exactly is the interior of the earth formed and in what variations do you get to see them, right? Just a minute. Yes, please come in. Right. So our today's topic is structure and interior of the, what happened? Okay, it is structure and the interior of the earth. In the structure and the interior of the earth, you primarily will be learning what are the reasons for the formations of these structures, what are the types of structures, or classification किस type का होगा. Now the earth's interior of the earth can be classified into mechanical composition, chemical composition, these things are there. So all of these things will be learning in detail. So structure of the interior. Right. So firstly, broadly speaking, how do you study what is there within the interior of the earth? What are the ways and means? Seismic waves is what people said. Other than that, meteors, volcanic eruptions, and please let me know online, am I audible or not? So there's no issue with the audio. Okay. Seismic waves, meteors, and then volcanoes. What else? What else? What are the other aspects? So deep sea mining. Deep sea mining also. Next. You might have studied. See, the structure of the interior of the earth can be broadly be divided into sources which are direct and which are indirect sources. Direct sources भी है, indirect sources है. Direct sources are, suppose on the surface of the earth, if you go on, keep on digging deep down, then you will get some material. Now this direct sources can be, one, by mining the material, other one is, you go deep down and drill into the interior of the earth, right? Volcanic material, whenever you get. Now the indirect sources materials are, you do not go deep into the interior of the earth, but still you get some materials, or when you study materials like earth, then that is some way when you study them into the laboratory, there you can get to understand that ये जो material है, it is having similar kind of earth kind of compositions, and then we can study them. So broadly speaking, there are direct sources and there are indirect sources. Now direct sources are, number one, it is mining. ठीक है, this can be continental mining or deep ocean. ठीक है, there can be continental mining and there can be deep ocean. See, if you have read your NCERTs, there are direct sources, खाली दो direct sources mentioned है. NCERTs में ये mentioned है, एक mining है, second one is volcanic activity. Right? Mining भी है, volcanic activity भी है. These are the only two direct sources that are mentioned, right? Now when it comes to the indirect sources are one. When you start to study the meteors, that also helps you in understanding what is there within the interior of the earth. But how is studying the meteors will help you what's there within the interior of the earth? कैसे? एज का पता चल जाता है, और यस, अर्थ जब फॉर्म हुआ था, see, when you are during the formation of the earth and earth's other bodies, they are nothing but sisters. They are sisters and they all come from the same family. When you look into the interior of the earth and you learn about the solar system, the entire solar system has come from one big theory called Big Bang theory. That is what we believe. And you also know that meteors are nothing but parts of asteroids, pieces of asteroids. They have different names at different stages. See, it might have been a planet, it might be a core of the planet, it might be a surface of a planet, but got cooled in a different set, or it might be still hot. When it comes onto the surface of the earth, that breaks down into pieces, and that material, when we are studying, it might be having similar characteristics that of an earth. And by understanding that, maybe the temperature that is present there, the temperature that is presently in what condition, like that we will be able to understand the size. Based on the size, density, materials and all, laboratory studies are helping us to understand the interior of the earth with the help of the indirect source such as meteors. ठीक है? Second one, other indirect source is gravity. ठीक है? आज आपको ये पता है that gravity near the polar region and the gravity near the equator region is not same. Why is it not same? Right? Suppose if this is your earth, right? And to be more specific, you have to draw the earth. The shape of the earth is like this. It is geoid, flat near to the poles and then bulged at the equator. And you know, earth has a core. See, the distance between the earth core, suppose this is point A and this is point B, and this is the center of the earth. The distance from the center of the earth to the equator is far than the distance from the center of the earth to the point A. Now the reduction in the distance is letting us to know that there is some kind of gravity differences. If we generally study the gravity differences or the gravity anomaly, that will help us to understand there is some difference or some material which is in the interior of the earth which is not same. ठीक है? Even by studying the gravity, you will get to know that the interior of the earth you can assess. Other area is laboratory studies. ठीक है? Next, any more? Before we enter into the seismic waves are nothing but earthquake waves or seismic waves. Earthquake waves bhi hai, seismic waves bhi hai. Now, before we go and study about the earthquake waves or seismic waves, do you think, is there any other source where you can study the interior of the earth? Online? Yes? Any other source? NCERT पढ़ा आपने? There is a chapter called Interior of the Earth. Gravity field. ठीक है. Next, magnetic field. See, magnetic field also helps in understanding the interior of the earth. Magnetic field, how is it helping? Anyone? How does magnetic field help to study the interior of the earth? Right? Poles. ठीक है. देखो, you have to understand the concept of magnetic field, how it is helping. Magnetic field lines or magnetic field anomaly भी कहा जाता है. See, You know that when the formation of the earth took place, earth was a hot body with so many volcanoes in and around, right? When the material of the volcanic material, when it is coming out, ठीक है, when it is coming out, it is a fresh rock. Do you agree to me? So the material which has come out, it now forms a rock. Now let us try to study this rock. See, a new rock, when it is freshly formed, ठीक है, imagine this is a rock. This is a fresh rock. When it is hot, before it is getting cooled, it will align itself with the magnetic field of the earth. Now imagine, you might have heard that the earth आज earth का magnetic north pole might be here and magnetic south pole might be here. I'm not talking about the geographic north. I'm talking about the magnetic field. Earth has its own magnetic field, right? Now that magnetic field, it keeps on moving. It's not the same place at which it is today. On an average, every year, the Earth's magnetic pole keeps on maneuvering or moving near about 45 to 50 kilometers. आज Earth का जो magnetic north pole है ना, it is in Canada. ठीक है, near to Canada. Like that, it keeps on moving. Why does it keeps on moving? Because there are some changes that we get to see within the interior of the earth. Even if you study the magnetic field lines of this rock, suppose this rock has been formed 50,000 years before. Now at that point of time, our earth's magnetic field lines, north pole might be here, south pole might be here. And if this rock is having ferrous component, then it will align its magnetic field in this direction. But imagine there is a volcanic activity this year, and that volcanic activity, when a new rock has been formed, these rocks, which are very, very fresh rocks, before they cool down, they will align with the magnetic field of the earth. And I told you, every year, ये जो magnetic field है, it keeps on maneuvering 50 to 60 kilometers. So sometimes the entire magnetic field also reverses. This topic we will learn in advanced classes in the optional, where I'll tell you how the magnetic field of the earth has formed. Okay. So now let's consider this as a fact that magnetic north pole might have also turned into magnetic south pole. ये south pole north pole भी बन जाता है. आज after 50,000 or 1 lakh years, imagine in today, our south pole might be here, north pole might be here. Or maybe after 1 lakh years, this could be the situation. This rock is having north pole here and south pole here, and this rock is having south pole here, north pole here. How? It is because there might be some changes in the interior of the earth. Even while studying this, you can estimate what is there within the interior of the earth. So that's why we also consider the magnetic field line study as also the indirect source of the interior of the earth, right? Now coming to the last component, that is your earthquake waves, seismic waves. Now this is considered to be the biggest authentic indirect source today which we rely upon. What is there within the interior of the earth, right? So you know that the deepest mining which we have done on the continent is still what kilometers? 12 to 13 kilometers. This is what the current research says. 12 to 13 kilometers is the interior depth which we went in and we started to dig. Beyond that, we are not able to dig that hole. Why? Heat, next. Only heat? Is it the only heat? Heat, कितना heat हो सकता है? Human नहीं जा सकता है, लेकिन machine तो जा सकता है ना? So then why are we not drilling that with the machine? देखो, firstly, mining में 2-3 issues हैं. For example, imagine that this is your earth, and earth की interiors, when you start to dig, right? So when you start to dig within the interiors, as you go deep down into the interior, the density of the material also increases, and the temperature of the interior of the earth also increases. And density, the materials that are available on the surface of the earth, you have mountains, plains, plateaus, all over, the material that you get onto the surface, they are not hard enough or denser enough to dig that area into that temperature. They melt off. Most of the materials that do melt off. So that's why we do not have humanly possible machines that can go dig deep down. Right? So that's why also other aspects comes into picture. Heat hai, material hai, density hai, right? And humanly aspects also. So that's why mining, the deepest mining that we have dug is only 12 kilometers. But imagine that you went and dug the same 12 kilometers into the ocean. Imagine this is your ocean. Okay. What happens to you when you dig 12 kilometers deep into the ocean? एक तो pressure है, दूसरी चीज, you will directly touch magma. You are already deep down into the 12 kilometers and then you start to dig into the ocean, you will touch magma. ठीक है? Because what is the thickness of the oceanic crust? The thickness of the oceanic crust is hardly, ये ocean की नीचे जो continent है, it is hardly 5 kilometers. Beyond this ocean, you dig deep down, this is all magma, right? So maybe you might be, this might be your continent, ठीक है? ये आपका continent हो सकता है. So you're digging deep down. Sometimes you have reached only till 12 kilometers. But if you dig here, directly you will touch the magma. So that's why it is not possible, right? So, but it's a direct source, directly we are digging deep down. Now come back to the next aspect, that is your earthquake waves. And till date, earthquake waves are considered to be the most authentic indirect sources, with some laboratory studies associated with that, right? So see here, let us try to understand the concept of earthquake waves for understanding the interior of the earth. Earthquake waves, now these earthquake waves are of two different types. One is body waves and other one is surface waves. How do you differentiate body wave and surface wave? In simple terms, when you look into the earth, right? Earth is a body. The body of the earth is nothing but, when you consider this earth, entire earth, imagine, ये जो earth है, when the waves are traveling from the interior of the earth, maybe 200 kilometers deep down, 300, 400, 50, 60, 70, they'll start to travel and come onto the surface. The place where we are living today is the surface. On the surface of the earth, we build our buildings, we build our any living elements, जहाँ पे forest है, trees है, oceans है, that is the surface. But when you go into the interior, that is the body of the earth. Now, where is the earthquake generating actually? The earthquake generates within the interior of the earth, right? And then what does it do? It sends some kind of energy, or it releases stress. That release of stress will create shaking of the earth. And that shaking of the earth is because there are some waves that have been sent. Okay? So when you start to study those kind of waves into the laboratory and apply that concept to your interior of the earth or the waves of the earthquake, then we are able to understand that as we are going deep into the interior of the earth, there are different layers. What are those layers? How do we classify them? That we'll deal in some time. Now come back. Suppose whenever there is an earthquake, what is the earthquake definition says? So Vipul says that moving of the tectonic plates. Next. Chahat. What is earthquake? How do you define earthquake? How do you define earthquake? Any way which you think definition of the earthquake? Shaking, vigorous shaking of the earth is nothing but earthquake, number one. Now during that vigorous shaking, it sends some waves out. Now that waves have some characteristics. Suppose I'm speaking here. What waves am I generating? Sound waves. That means I've sent my voice to your ears and there is a wave traveling all through the way in the air and you guys are able to hear. Right? Now other way, similarly, there are also waves that are generated by the earthquake. And that waves are, some are similar like sound waves and some are non-similar like sound waves. So those waves, when we start to study, we also understand the interior of the earth and it has some characteristics. Some waves can travel through solid, some waves can travel through liquid. So हमें पता चला कुछ ऐसी waves है which can travel through the interior of the earth, but they are not completely traveling through all the layers. So those things we have tried to understand. And in such a process, our earthquake waves have helped us to understand the interior of the earth. Before that, you first need to have an understanding about what exactly is an earthquake. An earthquake is nothing but a vigorous shaking of the earth. In this due process, some waves are sent. Now that waves can be broadly categorized into body waves and surface waves. What are body waves? Body waves are whenever the waves that are traveling through the interior of the earth, I'm talking about interior, inside the earth, that is nothing but body waves. Now the same waves, when they come and touch the surface of the earth, okay? See, suppose when they touch the surface of the earth, they become surface waves. Now you have mountains on the surface, plains, plateaus, some trees, right? Your houses, this is constructed on the surface. But when you go into the interior of the earth, there might be an earthquake that is generated at a depth of 200 kilometers or 150 kilometers, or from there, it will start to travel in the direction. Now, until it is traveling in the interior of the earth, it is nothing but body wave. But once it is the same wave, when it has come and touched the surface, it will travel through the surface like this. Now, the waves that are generated within the interior, it travels in every direction. It travels in every direction. It travels in every direction. Okay? And then, once it reaches the surface here, it travels like this. Right? The yellow color waves are nothing but surface waves. And these are body waves. So body waves and surface waves are the two broad category of waves of the earthquake. And in this, see, body waves have two different types. One is a P wave, other one is a S wave. Surface waves can be L waves and R waves. Okay? Love waves and relay waves. P waves are nothing but primary waves. S waves are secondary waves. Now the place where the earthquake is generated, or the place where the formation of the earthquake or the release of stress that is happening is called as focus. ये मान के चलो, this is called as focus, and the place where the earthquake will come and hit the surface of the earth, it is called as epicenter. Can the epicenter be here for an earthquake that is generated at a depth of 200 kilometers? Can the epicenter be here? Can the epicenter be here? Can the epicenter be here? So usually the epicenter is based upon the perpendicular distance to the focus. This focus is also called as hypocenter. Focus को hypocenter भी कहा जाता है. So focus is there, hypocenter. Here the energy is, the stress of the earth is released. That is what is nothing but your earthquake. In this due process, the nearest distance to the epicenter, the nearest distance to the focus will be your epicenter. आज ये मान के चलो 100 kilometers depth, at a depth of a place in which you are standing, if there is an earthquake that is generated at that point, the nearest distance from that point to the surface is the place where you will receive an epicenter. Okay? Right? Epicenter is the point at which the first surface wave, sorry, the first body waves have come and hit. Right? Come back. So broadly speaking, you have P waves, S waves, L waves, and R waves. There are some characteristics to the P waves. See, P waves are simply like sound waves. I'm speaking. Am I harming you? I'm not harming you because it's a sound wave. The characteristics of the P wave is also similar. It is also like sound wave. फिर तो P wave harm नहीं करना चाहिए. Is it? Is it true? I said that P wave is like sound wave. The characteristics of the P wave is nothing but like a sound wave. So if I'm speaking, if I'm not, my voice is not harming you, do you think that P wave should not harm you? See, the intensity of the P waves is way stronger, thousands of times stronger than the sound wave. It has a characteristics like sound wave. If there is too much of noise, what happens to the walls in and around? Don't they shake? They shake. Your P waves are nothing but sound waves, but that P waves comes with extreme intensity, right? But ये जो characteristics है ना, they are not much harmful as compared to the secondary waves and surface waves, right? Now P waves, their propagations are little different. Their propagations are parallel to the direction of the traveling, or suppose the propagation of the P wave is parallel to the direction of the movement of the wave. I know, ये जो शब्द है, it might be little difficult to understand. So firstly, let me tell you the characteristics. This is nothing but a parallel direction में travel किया जाता है. This wave travels in the same parallel direction in which it is generated. I'll show you an image that will give you a little understanding. And S waves are perpendicular to the direction of the propagation of the wave. S waves move perpendicular to the direction of the propagation of the wave, and P waves move parallel to the direction of the propagation of the wave. So it is perpendicular, it is parallel. Look, this is, let me show you how exactly they move. See here, this is your focus and this is your epicenter, right? There is focus and epicenter. Focus is the point at which the earthquake generates, and then you'll find an epicenter here. Epicenter is the point at which the first earthquake waves come and reach. Now look at this diagram. This clearly tells you there are two different types of waves. Imagine this is the point at which the earthquake has generated, and then it immediately releases two different set of waves. One is P wave, which is primary wave, which travels faster, and there is S wave, that is secondary wave, which is generated a bit later. Okay? So you see, the pink color component or the pink waves are nothing but secondary waves. These are P waves. कुछ ऐसा अगर हमारे पास, if you have an idea where we can stop or we can predict that the earthquake is coming, ठीक है? We will go have some water and come. ठीक है? So there are these P waves, they are the first ones to reach. After P waves are after P waves are released, you will find these are S waves, right? Just a minute, okay. So look, these are your P waves and second waves. If we have a technology where we can record the P waves, which are not much harmful, but when S waves come and arrive, they are the most harmful entities. तो हमारे पास अगर ऐसा टेक्नोलॉजी हो, जैसे P wave strike किया, we will start to make the alarm all around, saying that earthquake आने वाला है, तो shut down all the emergency inputs or all the emergency services जहाँ पे disaster हो सकते हैं. For example, nuclear facility is there. If the nuclear facility is experiencing earthquake, chances ये है जहाँ पर large scale destruction हो सकता है, thermal power plants, very extreme emergency inputs. So it would be very helpful, but today in the world there is no technology that we today have to predict the earthquake. इसीलिए earthquakes are considered to be the one of the most deadliest disasters. And come back, so as it sends these two set of waves, firstly, we generally try to study the P waves and we also try to study the S waves as well, right? So there are many laboratory studies. In this laboratory studies, आज हमारे पास एक छोटा सा टेक्नोलॉजी है जो मिनिस्ट्री ऑफ अर्थ साइंस काम कर रहा है, that early earthquake warning system, but the early earthquake warning system will work in a matter of hardly 1 to 2 seconds early warning, that's it. Not much of time is there. मतलब P wave पहुंचने के बाद S wave hardly within a second it will reach, or 2 seconds, 3 seconds के अंदर ही it will go and reach. So that's why we do not have much amount of time, right? Come back, we were discussing about the P waves and S waves. Look, see, this is a longitudinal wave and there is a transverse wave. Look very carefully. This is a longitudinal wave, and let's see the transverse wave. This is a transverse wave. Now P waves are considered to be longitudinal, S waves are considered to be transverse, right? I'll show you that ये जो P wave है, it is longitudinal. S wave, transverse. L and R wave, transverse. Right? Now let's try to understand what is longitudinal wave, what is transverse wave, and how they are helping to study the interior of the earth. Right? Before that, you have to know that P waves can travel through solid, liquid, gases. S wave can only travel through solid. ठीक है? P waves can travel through solid, liquid and gases. S waves can only travel through solid. So by this logic, whenever an earthquake is generated, we got to know that there are some layers within the earth. How? Wait for some time, you'll understand. Come back. I told you P waves are like sound waves, which are longitudinal waves. S waves are perpendicular to the propagation of the direction in which they travel, and they can only travel through solid, and they are transverse waves. See, once look into the characteristics. This is your longitudinal wave. Imagine that you have a house. ठीक है? Imagine that this is your house. ठीक है? When I press this again, it will go. Just a minute. This is how the shaking of the waves happen. Look, longitudinal waves, they are only moving in this direction. Now imagine in the transverse wave within the same house which you have, how these waves travel. Will there be much damage in the first case or in the second case? Second case. So to be more specific, let us try to understand this earthquake waves. Suppose this is your earth. On the earth, you have constructed your home, right? First, let us try to understand the P waves. Imagine that there is a P wave which is generated, right? What does this P wave, how is it moving? It moves in this direction. P wave is moving in this direction. While it is moving, what does the wave do? It actually stretches and squeezes. The wave is moving in this direction, but it is stretching and squeezing, right? What is the direction of the movement of the wave? The wave traveled in the direction, in this direction itself, right? Now, come back. So, it actually, your wave will also travel through in this direction. Now, what does it do? It actually stretches and squeezes the material in your house, right? That means the building material will be stretched and will be squeezed, right? Number one. But when it comes to transverse waves, look at these transverse waves. This is longitudinal. Let's wait for the transverse. Okay, this is your transverse wave. Earlier, the materials were stretched and squeezed, right? But now, see, the materials are lifted up and then dropped down, lifted up and dropped down, but the wave is traveling from in this direction, right? They are lifted up and dropped down, but the wave is traveling in this direction. So, earlier case you got to see that the materials of your house are stretched and squeezed, but now, along with the stretch and squeeze, what is happening? The wave will be traveling in a different direction. Look, it is creating a trough and a crest. Okay, now let's go back and let us try to understand the same situation. Imagine this is your house and the secondary wave which is generated, this wave, this is how the wave travels, right? In which case do you see more damage? This is P wave, this is S wave, S waves. Okay. Now this is for a general understanding which I have told you, but look here, the direction of the wave is moving in this direction, but the materials are stretched and squeezed. The direction of the wave is in this direction, but the materials are moving sideways, moving this way. It created a trough and crest. Do you agree? Is there anyone online who did not understand this concept? Anyone who did not understand this concept? If you do have any doubts, you can message me. I'll be waiting for 10 to 15 seconds. Yes? Okay, let's move ahead, right? Are you clear with this? Because we are going to apply the similar concepts in the further classes as well. So usually, this is the case of the S wave. Now this is called as a wave which is perpendicular to the propagation of the direction in which it is traveling, and this is called parallel wave to the propagation in which the direction it travels. And simply, to make this in a simple way, see here, what is this perpendicular here? Perpendicular is nothing but, look, the wave is traveling in this direction. Wave actually traveled from point A to point B. What is the direction of the travel of the wave? It is like this. But the materials in this are moving. Ye check karo. Let me draw to point B. Okay, let me put it in a different way. From point A to point B, the wave traveled. Now here also, let's consider this is point A and this is point B. In the case of, okay, let's keep this as C, right? In both the cases, from point A to point B, the wave traveled. what is the direction of the wave? The direction of the wave is like this, right? But look at the materials which they are squeezed or which they are moving. In this, the materials will be moving like this, right? But here, the materials will be stretched and squeezed. Matlab, they stretch and they squeeze, but here, the materials get shaked. Look, here, the materials movement will be like this. In simple terms, imagine these are the points. Let's consider these are the points. It is actually perpendicular to the direction of the propagation in which travels, right? Inka angle kya? 90, 90. So this is how it is seen in a simplest way if I have to explain this. So most of the students do have the confusion, sir, what is this perpendicular, what is this parallel? Look, here they are parallel to each other. So parallel to the direction of the propagation of the wave. That's why P waves, though they create damage, their damage is such a way that it is not creating intense or similar kind of damage like an S wave. They also create damage. It's not like that they do not create a damage, right? But when it comes to S waves, their damage is very high. Now come back and see the conditions of the other waves. Let's see the secondary waves and surface waves. We have studied about these waves right now. We have studied about these two. One is primary wave, other is secondary wave. This is P and S wave. These two are body waves. We have to study about the secondary waves, sorry, S waves. In the S waves, the movement of the particles are very intense. Because of that, look, this is a general representational image of a wave when it is traveling from here to here. See, P waves, in which of the following waves do you find the highest damage? Love waves, ये हमेशा problem है, ठीक है? Now it is one of the most dangerous wave. R wave is also a dangerous wave. L wave is also a dangerous wave. These two waves, they do have a different set of propagation. ठीक है? उनका propagation ही अलग है. It moves the material in an irregular manner. Here we at least got to know trough and crest. The materials get to move in trough and crest manner, but here they move in an irregular manner. Now let us try to understand the propagations of this P waves and S waves, how exactly they move, and L waves and R waves. Look, this is an R wave. In the R wave, see, look at the propagation of the wave. Imagine you have your house here. Okay? Just imagine that you have your house here, or a big building. When there is a wave that is moving in this direction, creating troughs and crest, and it is also moving in the side waves like a snake. And L waves are also called as snake moved waves, or the snake movement like waves, right? If you read the advanced books, वहाँ पे एक छोटा सा column में लिखा होगा snake waves. It is nothing but these, because their particle motion is in the opposite direction, right? Look at this dot. It moves in this direction and it again comes back to the different direction. So that's why these kind of waves are very, very dangerous, and these waves travel on the surface. You might have seen the Turkey earthquake. Abhi recently काफी ज़्यादा नुकसान हुआ, right? Now what waves? It is nothing but the surface waves that create this damage. On the other side, look at the R waves. R wave का particle motion देखो, it is circular, right? This is how the particle motion happens. Now look at the S waves. We have studied about the S wave. S wave only create troughs and crest, trough and crest like this. Look at the P waves. P waves only stretch and squeeze. Right? Now, this is what is the nature of these waves. By using these waves, we try to understand the interior of the earth, right? Now remember, whenever there is an earthquake in the interior of the earth, it sends its waves in all the directions. I'm telling, it sends its waves in all 360 degrees, but it might lose its intensity, it might lose its velocity based on the material it is traveling. See, suppose there is an earthquake. Imagine this is your earth, and then there is an earthquake at this point. When there is an earthquake that is generated, or this is the focus, from the focus, the waves will be traveling in all the directions. This direction, this direction. It is like this. Now these are what? What are these waves? Are they body waves or surface waves? Yes, the body waves travel through the entire body of the earth, but some waves, they might have the capacity to cross the various layers within the interior, and some waves they do not have. Now immediately after this, you also have another wave coming up, right? That is surface wave, sorry, secondary wave, not it is secondary wave. So here the body waves characteristics, like P wave, it can pass through solid plus liquid. S wave, it can only travel through solid. Now when it touches liquid, the wave dies off, right? Clear? Now solid, liquid, and in some books you will also get to see as gaseous. In every medium this can travel. If I'm able to speak the sound wave, it is able to travel through the gas and you are able to hear it, right? The frequency keeps on varying into the sound waves, and the intensity keeps on varying into the sound waves. So my question here is, so if you have an earthquake, right? If there's an earthquake and you have an aeroplane traveling here, will that aeroplane shake? Q? What did I say? P waves can travel through solid, liquid, and gas. The P waves should also move into the air and shake this also. Will that happen? Surface waves, it will generate a set of new surface waves. इतनी powerful नहीं होगा, but लेकिन वही plane अगर surface पे हो तो तब तो होगा. It has that power to shake this plane also, but what happened in between a plane which is here and a plane which is here? देखो, P waves जो है ना, they are mechanical waves. It needs a medium. Gas is also one of the medium, but it needs mechanical wave. It is a mechanical wave, means it needs an object to travel to shake that. Clear? So P waves are also called as mechanical waves. Mechanical waves do need a medium, right? And whenever they change the medium, their velocity changes and the speed of the wave changes, nature of the wave changes. They also reflect, they also refract, right? Suppose they are moving from liquid to solid. Solid has more density. Now the nature of the P wave is that P wave will travel at a faster rate in the solid. S wave, it will travel faster in the solid. When it touches the liquid, it dies. It cannot move in that. But P wave do travel to that liquid, but it will travel at a lower speed. The velocity of the material decreases. And then when we study these kind of patterns within the interior of the earth, कभी P wave का speed बढ़ रहा है, कभी P wave का speed कम हो रहा है. जहाँ पे P wave का speed कम हो रहा है, वहाँ पे S wave absent है. इसका मतलब ये है, अर्थ के अंदर there is some kind of liquid layer also. There might be some kind of solid layer also, right? That is how we got to understand within the interior of the earth what kind of layers we have. Suppose here, see, imagine when there is an earthquake. Today, आज की ज़माने में तो our earthquake, we are able to predict we are able to measure at what magnitude it is and what is the intensity of the earthquake, right? How are we able to measure what is the magnitude, what is the intensity? See, we have a device by the name, we have, what is that, Richter scale? What is seismograph then? Right? Have you ever seen the machine? How does that work? See. Usually, this is how exactly a seismograph works. This is called vertical seismograph. आजकल यही system horizontal also it will be there. Look, in this particular system, this is from an iris, I have taken it. So it will always be hanging. Okay? There will be a hanging bar, and in that hanging bar, it always draws the graph. Whenever there is shaking of the earth, the shaking of the earth will be drawn on the graph. And this graph will measure what is the intensity of the earthquake. Okay? Right? Sorry, this is what is the magnitude of the earthquake, not the intensity. Intensity is how much damage it has caused is intensity, and how much it has shaken the earth is magnitude. Now look here, you can see there are two lines that are drawn, 1 and 2, right? It is nothing but these kind of graphs you also see in your NCERT, but you have to understand them on a practical note, especially in the optional, ताकि लंबे time तक याद करें. Now, one wave and two set of waves. Now, these two set of waves are like this. So first, this is your P wave, right? That means primary waves, whenever it came, the machine has drawn this. Then you have S wave. Then you have surface waves. Look at the magnitude of the surface wave, right? Large shaking. These surface waves are generally damage creating waves which have different set of propagations. They also move straight, they also circulate, they also move irregular transverse movement, right? They can move all the steps. So broadly speaking, this is how your seismograph will help you in understanding the intensity of the magnitude of the earthquake. Now when it comes to intensity, intensity is nothing but jitna kitna shake hua tha, उस shaking के कारण how much is the damage that is created, that is your intensity, right? See, now by using these methods, what did we do? We kept our seismographs. Imagine this is your earth. On the earth, today, you have seismographs placed at every important place. Imagine these are the seismographs. Right? ये मान के चलो ये सब seismographs हैं. The machines that we have seen. Now, see, there is an earthquake which is generated, or which is the focus of the earthquake is at this depth. Now there will be waves that are generated through every corner of the earth, but lekin our epicenter will be perpendicular to the focus, because this is the nearest distance and this is where the highest magnitude of the earthquake can be seen. Now the same wave, if it has to travel through longer distances, its velocity might change, its intensity might change, and also various mediums it has to go through, right? Like this, there are some areas, if suppose this is your P wave, whenever an earthquake wave is generated, your P wave has been not noticed in few areas, right? Like that, immediately after that, you also have S waves, right? S waves coming behind, S waves coming behind, S waves coming behind. Now, few seismographs which are placed at nook and corner of the earth, they did not recognize S waves. Now, wherever the S wave is absent, that is called as S wave shadow zone. Wherever the P wave is absent, that is called as P wave shadow zone. In simple terms, if I have to tell you, imagine there is no S wave in this region, ठीक है? S wave यहाँ S wave notice नहीं किया गया. इसका मतलब ये है ये एस वेव का शैडो जोन है, राइट? और एल्स लेट्स कंसिडर दैट in these particular areas P wave is absent. So this is your P wave shadow zone. Like that, shadow zones are identified. Now in this due process, you see, we got to understand that there are some areas where P waves are absent and there are some areas there are S waves absent. After a very big project, now if you study the geodesy there, you got to understand that it is a project which has been coordinated project for around 30 odd years. The mapping of the earthquake took place, and that is when we got to know the shadow zones. See, an earthquake which is having an epicenter here, it got to see the P waves traveling through most of the area. Okay, it got to see they are found here. But the same earthquake, it is not having the S waves in few areas. Okay, this is how your S waves got to see. And this is how you got to see the P waves. But S waves are absent in these regions. Why? आपको ये पता है ना, P waves travel through solid, liquid and gas. S waves travel through solid only. If the S wave is absent here, it is an indication that it might have hit a liquid layer somewhere. That means there might be liquid layer within the interior of the earth. And then we came to a conclusion, okay, within the interior of the earth, there might be a layer which might be having liquid. Right? Clear? But in the same area, you also got to see some P waves traveling through that. मतलब P waves तो आ रहा है, लेकिन S waves absent है. क्योंकि P waves, when we started to study similar kind of studies in the laboratory, we got to understand that S wave can only travel through solid and P wave can travel through both solid and liquid. Now this kind of indirect studies have revealed that our earth is having a liquid layer. P wave or S wave? Reason behind missing of the P wave. I'll come back. People asked the question, sir, what is the reason behind missing or the shadow zone for P wave? That is what, right? It is because, see, P wave, it can travel through solid, liquid and gases, but P wave का दूसरा characteristic ये है, P wave, it is faster in high density materials. ठीक है? The same P wave is slower or the velocity is reduced in the less density materials. And then the nature of the P wave is that ये जो P wave है, whenever it passes from solid to liquid, the wave refract. Refraction, you write? You might have studied in your schooling days that if suppose if you are sending a race, imagine this is a solid and this is a liquid. A ray, when it is traveling through this, it will not travel in a straight line. Suppose if you are sending, it will not travel in a straight line. It either bends, right? Angle change hota hai na? So that kind of activities were happening within the interior of the earth. So because of the refractive properties, in some areas, your P wave is also absent. Look, your P wave got hit to the solid layer, liquid layer, and then it bends, right? So that's why your P wave is also absent in these areas. क्यों? Yes, path change हो गया. ये solid layer था या liquid layer था, it has changed and its paths changed. Like that, there is some shadow zone that is left here. Like this, we got to understand the various areas of the shadow zone. When we start to study these shadow zones, it is understood that it has helped us to reveal that the interior of the earth has different layers. Now that interior of the earth layers are like this. You take up the earth, the outer layer is called as crust, and you go little inner, you have three different layers. One is crust, mantle, and core. Right? This core can be studied, this core is divided into two layers. One is inner core and the outer core. Within this core, you have inner core and this is outer core. Suppose, now imagine, ये जो inner core है, if it is solid and outer core is liquid, imagine, this is solid and this is liquid. I'm only asking you to imagine. Suppose if you have a P wave, if you have a P wave, it comes, but it refracts, again its speed increases, and then it goes. Right? It comes, it refracts, again it travels to greater speed, it comes out. This is how the P wave comes out. Now imagine like that your P wave has traveled through these layers. But what about the S wave? Green color is an S wave. So S wave, while it touches, it dies off. S wave dies off. S wave dies off. It dies, it kills, or it gets killed. So do you find the S wave? Do you find the S wave, a seismograph which is placed here? Because your S wave is like this bus. It cannot pass through the liquid layer, right? So this particular area is called as S wave shadow zone. ये जो shadow zone area है ना, जहाँ पे shadow means right? So with the help of the shadow zones and the speed of the waves, when we start to measure them, it is an indication which told us, or it is the studies which have helped us to know that Earth is having a liquid layer, and that is your outer core. Inner core is solid. Right? Now, just above this, we got to understand that P waves and S waves which are generated here, this is where your P wave and S wave generated. These waves, you have both P waves and S waves here. Right? Let me show you a small image which will help us to understand in a better way. Look, this is the path of the P waves. P waves, if you see, here P waves are absent between this area, and P waves are absent here. And this is called as P wave shadow zone. Now, let me replay. Why are they absent there? क्योंकि ये जो outer core है, it is liquid. Whenever this is passing through the liquid layer and one medium to another medium, it is getting refracted, it is getting bent. Is bending areas में you got to see them. Right? Now let us see the S wave. S wave can only travel through solid, it cannot travel through liquid. Look, as soon as it touched the liquid layer, it got dead. So by this logic, you got to understand that the shadow zone of S wave is larger, or the shadow zone of P wave is larger. S waves, right? Now there is a difference in number. 103 degrees से लेकर 103 degrees तक एक book में दिया होगा, 105 to 105. It is like that. A number is not much important, but here you need to know that S wave has a larger shadow zone. If you see, if I have to draw it again, this is the shadow zone of the S wave, very big 103 degrees to 103 degrees. But P wave shadow zone, your P wave zone, ये है आपका P wave shadow zone, right? Now S wave shadow zone is very large. Now let me redraw it. Got it? That means these waves have helped us to understand the interior of the earth. Now if you go into little more deeper, and in the next class we'll be studying about the layers of the earth. Earth के अंदर किस type की layers है? In that layers, what is the role of this P wave as it is passing from one layer to another layer? What is the speed it is maintaining? And then why is it bending? And what are the layer names? Now the layer names are divided into on the basis of the mechanical composition, on the basis of the chemical composition. So like that, we got to know about the interior of the layers of the earth. And one more revealing factor is that the P wave, as it went into the deeper into the interior of the earth, its speed increased. It did not decrease. Why? Because as you go into the interior of the earth, the density of the material of the earth is increasing. Even if you understand, or if you look into the reference, I told you this is a liquid layer, right? And this is a solid layer, and this is a solid layer, right? Core, outer core is liquid, inner core is solid, and then rest of the layers are solid, and some semi-plastic, semi-molten layers hai, plastic layer jaisa bhi hai, that I am going to tell you in the next class. Here, liquid hai, but the density of this, even this liquid layer is very higher than the density of the material that is present on the surface of the earth. I asked, if you take mercury and if you take iron, which is more heavier? Iron. Or else if I take iron and put into mercury, will the iron sink? किसका डेंसिटी ज़्यादा है? मर्क्यूरी का डेंसिटी ज़्यादा है. आयरन का डेंसिटी कम है, 6 to 7. Mercury का डेंसिटी 11, 12. You put a piece of iron into the mercury, iron will float on the mercury. But on a molten iron you put mercury, mercury will melt, mercury will sink. Same is the case. Here, the density of the material which is present on the surface of the earth is less. But when you go into the interior of the earth, the density of the material will be more. It's just like mercury. Imagine this is a very high density layer which is liquid. Mercury at room temperature is liquid. You can see that flowing all over. But you put iron on it, it will not sink there. It will float on the mercury because density of mercury is more and the density of iron is less. Similarly, the density of the liquid is higher here than the material that you see on the earth. Continent, mountains and all, we feel that they are more harder. No. They are more denser. No. There are more denser material in the interior of the earth. Right? Clear? Any doubts? Okay. Now on this basis, with the help of P waves and S waves, we later understood that the interior of the earth is having different layers. Now let me show you the layers. The layers of the earth can be broadly divided into 1. Inner core, outer core, mantle. Within the mantle, you can have upper mantle, you can have lower mantle, then you have crust, that is continental crust, and there is also oceanic crust. Right? So when these waves are traveling to the continental crust and then it entered into the upper mantle, the speed of the waves increased. Again, when they went little lower, increased. So in spite of they coming into the liquid layer, their velocity did not decrease, only the refraction happened, the angle of the waves changed. By this we got to understand that the material of the density is also higher, because similar kind of studies we have also done it into the laboratories. Clear? Now if you study more specifically, the composition of the earth or the interior of the earth, structure of the earth can be divided into two different types. One based on the chemical composition of the earth, and the other one based on the mechanical composition of the earth. You know that earth has core, right? Earth has mantle, earth has crust. Suppose if you study the earth as crust, mantle, core. Now this division is called as structure. But when you study the mechanical structure of the earth, you will understand that there are multiple layers. So here you will have another layer like this. What is this? Asthenosphere. Okay? And then you have outer core, you have inner core, you also have mantle. Mantle ke andar alag layers hai. Here you will also study about the discontinuities. Moho discontinuity, Lehman discontinuity, and Gutenberg, Conrad, Repti. What are these discontinuities? Discontinuities are nothing but whenever a material or the waves that are traveling, they were able to maintain the same speed. See, if suppose I told you that there is a layer called inner core and outer core, imagine this is your liquid layer, this is your solid layer. अचानक से solid बन जाता है क्या 1 किलोमीटर के अंदर? No. The depth of these materials is near about 6,000 kilometers deep. Our earthquake which is generating, hardly on an average the earthquake that generates is 100 kilometers deep. Or else the maximum deepest earthquake till date we have seen is around 580 or 600 kilometers. उससे depth का earthquake हमने आज तक देखा नहीं है. That means the earth started to shake from here itself. And those waves that travel and then come onto the surface. Coming back, if you see the outer core, ये liquid है, ये solid है, right? But लेकिन ये liquid to solid, it will not transition just in a matter of a kilometer or 2 kilometers. It slowly changes. That slow process of change which is there, now that it has some discontinuities. Continuity manner में वो नहीं है, discontinuity है. ये continental crust से upper mantle के बीच में there is some kind of discontinuity. Continuous composition is not there. That is based on the mechanical composition. Is it hard rock, soft rock, or is it molten material, or what is the composition? Like that, we started to differentiate that layers. Now, in a depth manner, we'll study all of this in the next class, but this is just for your understanding. Now, our earth can be divided into multiple layers, right? The topmost layer is the crust, then you have mantle, then you have core. Within the mantle, upper mantle, intermediate mantle, lower mantle. 3 types. Core, outer core, inner core. Crust, continental crust, oceanic crust. Now the difference between continental crust and oceanic crust is that, see, the place where we are standing is nothing but continental crust. Now within the ocean also, you go to the floor of the ocean, not on the surface, जहाँ पे पानी नहीं है. Depth of the water, there you will find oceanic crust. And the material that is found on the oceanic crust is not the same material that you see it on the continental crust. Now if I ask you a question, is the continental crust density higher or the oceanic crust density higher? Why, if the oceanic crust density is higher? ये तो ठीक है, चाहत ने ये बताया सर यहाँ पे बसाल्ट का रॉक होता है. बसाल्ट का रॉक हो तो यहाँ पर क्यों डेंसिटी हाई? We generally think that the continents are stronger, right? But we now, No. We'll study in the optional. Here, it is because from the interiors. This you'll get to know about clarity only in the rocks chapter when we study why the density of the oceanic crust is high and why the density of the continental crust is low. Remember one thing blindly. अगर density ज़्यादा है तो that will sink. अगर density कम है that will be lighter. Right? Did we study the Big Bang theory? In the Big Bang theory, if you remember, I told you about two words: differentiation and accretion. Differentiation मतलब क्या? The heavier materials are always towards the center of the earth and lighter materials are always on the surface of the earth. The density of the materials as you go higher are deeper and the density of the material on the surface are lighter. But look here, but the depth of the continental crust. If you are not able to understand this diagram, let me redraw it. Imagine this is your earth. On the earth, these are your mountains, and just imagine that this is your ocean. ठीक है, ये आपका ocean है. What I'm trying to do is I'll be drawing this on a sideways. Suppose these are your mountains, crust, and then this is your ocean. See, the thickness, I'm talking about the thickness. Thickness of the oceanic crust ये जो है, it is only hardly जो thickness है ना, it is 5 kilometers. You go into the ocean and drill deep, you'll find the magma in just a matter of 5 kilometers. But here, the thickness of the continental crust can vary between 30 to 70 kilometers की बीच में. Now this can be 30 kilometers and this can be 70 kilometers. Right? But density wise, this is more heavier and this is lighter. Right? Clear? So whenever, imagine there is a plate called oceanic plate and there is a continental plate. If they two collide with each other, which will get damaged? Or else which will sink? I'm asking a question again. If the oceanic plate and the continental plate, they collide with each other, which will sink? Q? The density is high, it is heavier. So always remember, I did not teach you about the plates, that plates concepts and all. In the next class I'll teach. Here, the denser material will always sink and the lighter material will always be there. Today, if you see, there are many plates that are present. There are continental plates, there are oceanic plates. Continental plates and oceanic plates, whenever they collide, imagine this is continent, this is ocean. When they collide with each other, it is actually the oceanic plate which is sinking into the mantle. Now sinking, see, for suppose, let us try to understand this. यहाँ पे for some reason there is a break. So I'll redraw this. Imagine this is your oceanic plate and this is your continental plate. ठीक है, ये दोनों आपस में टक्कर कर रहा है. So it is actually this plate which will go and sink, and here it will melt. Right? As this gets melted, it starts to raise the magma and it punctures out the continental crust, and here itself you got to see this volcanoes. Right? It is actually both the plates, when they collide, the density of this plate is high and this plate will go and melt. While it is melting, it creates the magma. Now why this is melting, why this is going, we will learn in a very detailed manner in the geomorphology, but this is the basics class. Taki, when I use the technical terms, you should be in a comfortable way to understand the further classes. If there I'll be using directly the continental collisions or the oceanic continental collisions, because of which the various density variations, you should not be confused there, right? This is the reason why the basics of geography is taught here, right? So as they start to see the volcanoes, now a similar kind of representative image I'll be showing you, how exactly the process of the entire continental collisions or within the interior of the earth, what kind of changes that you get to see. And all of this we'll be studying in the advanced classes, but look, there is a lot of magma in the mantle, and there is in the outer core also. On a continuous basis they'll rise. Why they rise and all, I'll give the reasons in the further classes. But when they start to come up, usually along with this its movement, it will also move the materials, or it will move the entire crust. When it is moving, sometimes two plates can diverge or two plates can collide with each other. Divergence and collisions will lead to the formations of the volcanic activity. In both the cases, divergence may be, collision may be. Now this is a collision activity. Imagine this is your oceanic plate. It is going and melting here. Because of the melting materials, you will get to see volcanic activity on the other plate. This is your oceanic plate. Imagine it is melting. As it melts, it starts to punctures the continental crust, and it punctures and then comes out. This is your volcano, right? So if we are studying this volcano, it's a direct source which is coming from the interior of the earth. Every time, whenever we get to study this, abhi material ka density kya, zyada ho sakta hai, kam ho sakta hai, from what depth it is coming, we can analyze. So these are some direct sources. Indirect sources are also there, we'll study. And in a detailed manner, only in the further classes, we'll be taking up this, right? So there are many number of plates on the surface of the earth. Regarding the continental rift theory, we'll be taking up in the further classes itself. Today, we'll stop here. And any doubts, if you have my contact number. That is, just a minute, let me write it here. And my name is Madhusudan Reddy. Just drop a message if you do have the doubts only regarding these topics, not the other topics. ठीक है, other topics जब तक मैं आगे नहीं पढ़ाऊंगा, until then I'm not going to reply for these additional topics. ठीक है, only for these topics whatever we have taught. See you and thank you. We'll meet in the next class. एक मिनट.